In recent years, something strategic and silent has happened in global space exploration. After decades pointing to Mars as humanity's great destination, the focus has clearly and intensely shifted back to the Moon. For a long time, Mars was presented as humanity's next home. The red planet symbolized expansion, survival, and even a possible alternative if something went wrong on Earth. Visionary entrepreneurs, space agencies, and governments placed Mars at the center of technological promises. Martian colonization seemed inevitable within a few decades, according to widely promoted optimistic speeches. However, as plans became more concrete, technical reality began to weigh more heavily than enthusiasm. The complexity of a mission to Mars revealed challenges far greater than the public had imagined. It was in this context that the Moon returned to the center of strategic decisions, not out of nostalgia for the Apollo missions, but out of practical necessity and long-term planning. The difference in distance between the Moon and Mars is the first decisive factor. The Moon is relatively close to Earth when compared to vast interplanetary distances. A crewed trip to the Moon takes only a few days, allowing for a quick return in case of emergency. This reduces operational risks and increases the safety margin for experiments and testing. A mission to Mars, on the other hand, requires months of travel, prolonged exposure to radiation, and no possibility of immediate rescue. This factor alone completely changes the level of risk involved. Communication also weighs heavily in this strategic equation. Between Earth and the Moon, signal delay is almost imperceptible and allows for near real-time control. Between Earth and Mars, the delay can vary by several minutes, making any decision dependent on the full autonomy of the crew and automated systems. Another central point involves costs. Interplanetary missions demand exponentially greater investment in fuel, life support, and shielding against cosmic radiation. The Moon, being closer, allows for more frequent testing with relatively more controlled budgets, making technological advancement more gradual and sustainable. In recent years, important discoveries have transformed the Moon's importance. Evidence of water ice in polar regions has completely changed the natural satellite's strategic value. Water means the possibility of producing oxygen for breathing and hydrogen for fuel. This transforms the Moon into a potential space refueling station. This ability to generate resources locally drastically reduces the need to transport everything from Earth, lowering costs and increasing the autonomy of future bases. Mars also has ice, but extracting, processing, and using these resources requires much more complex infrastructure that is difficult to implement. The Moon therefore emerges as the ideal laboratory for developing space mining technologies, energy generation, and survival systems beyond Earth. From a geopolitical perspective, the space race has never been purely scientific. It has always involved power, influence, and technological leadership. Establishing a permanent presence on the Moon means dominating near-Earth space, creating strategic advantages in communications, defense, and orbital economy. Recent programs reinforce this lunar priority. The current goal is not just to land again, but to remain and build sustainable infrastructure. This new approach completely changes the concept of exploration. The Moon stops being a symbol of conquest and becomes a strategic territory. Meanwhile, Mars continues as a long-term objective, but with a more cautious and technical approach rather than an emotional one. Radiation exposure during a Martian mission is one of the greatest scientific challenges, still without a definitive solution. For months in deep space, astronauts would be vulnerable to solar particles and high-energy cosmic rays. On the Moon, exposure time is much shorter, allowing protective solutions to be developed before facing the long interplanetary journey. There is also the psychological issue rarely discussed publicly. A mission to Mars implies extreme isolation for years, with no possibility of immediate return. On the Moon, missions can be rotational, with frequent crew changes and closer support from Earth. Private companies also influence this shift in focus. The near-Earth space economy is beginning to become a concrete reality. Satellites, orbital tourism, mining, and space stations create more immediate financial opportunities in the lunar environment. Mars still does not offer a viable economic model in the short term, making investments riskier and politically harder to justify. Another relevant factor is public narrative. Returning to the Moon allows for more frequent and visible achievements, maintaining society's interest. Mars requires decades of planning, something difficult to sustain within short political cycles and constant changes in government priorities. International cooperation also favors lunar projects. Several countries participate in joint initiatives, sharing costs and technology. This collaboration reduces financial risks and increases strategic stability, creating a solid foundation for future advances. The Moon represents a logical intermediate step within a broader strategy of human expansion into space. Ignoring this step could mean repeating historical mistakes of advancing too quickly without consolidated technological foundations. Today, prioritizing the Moon does not mean abandoning Mars. It means structured preparation for a safer leap. Each habitat module tested on the Moon reduces uncertainties about survival in hostile environments. Each air and water recycling system validated on lunar soil decreases risks in future interplanetary missions. Each experiment with crop cultivation in reduced gravity contributes to the Martian dream. There is also the aspect of orbital infrastructure. The Moon can serve as a platform for more distant missions in the future. Launching rockets from an environment with lower gravity requires less energy than launching from Earth. This could make interplanetary travel more efficient and economically viable in the long term. The shift in focus, therefore, is not a setback. It is a strategy based on data, calculated risks, and technical feasibility. Mars remains the dream that inspires imagination and ambitious projects. The Moon is the concrete plan that builds the necessary steps to reach that dream responsibly, strategically, and sustainably over the coming decades of space exploration. In the current scenario, consolidating a lunar presence is not only technical prudence, but also a decision aligned with economic, political, and technological realities that shape humanity's future in space. The history of human exploration shows that great leaps never happen impulsively, but are supported by solid and carefully planned intermediate stages. First, we explore nearby territories, learn to survive in them, develop infrastructure, and only then dare to cross much greater and more challenging distances. First, we mastered Earth's orbit, then reached the Moon, and now logic points to transforming the Moon into a base before attempting to conquer Mars. Ignoring this strategic progression could mean compromising decades of investment, putting lives at risk, and delaying the advancement of human presence in deep space. The true reason why attention has turned back to the Moon involves operational safety, cost reduction, progressive technological development, and global geopolitical positioning. Mars has temporarily taken a secondary role because it requires robust solutions to problems such as intense radiation, prolonged isolation, and full autonomy of critical systems. These challenges are still being studied, tested, and improved, and the Moon offers the ideal environment to validate these technologies under real conditions beyond Earth. This does not mean that the Red Planet has ceased to be a strategic priority within the long-term plans of space agencies and private companies. It means humanity is choosing to build solid foundations, both technological and logistical, before taking the greatest interplanetary leap in its history. A permanent presence on the Moon could inaugurate a new era of space economy, with mining, fuel production, and orbital infrastructure expanding commercial possibilities. These initiatives create financial sustainability for future missions, reducing exclusive dependence on government funding and expanding private sector involvement. By transforming the Moon into an operational platform, humanity establishes an advanced outpost that facilitates scientific, commercial, and eventually crewed missions beyond Earth's orbit. This gradual approach increases the probability of success when we finally decide to send humans to Mars permanently rather than merely on experimental missions. At its core, the decision to prioritize the Moon is not a lack of courage, but a demonstration of strategic maturity in how we plan to expand our presence in the cosmos. Each step on the lunar surface represents a full-scale rehearsal for far greater challenges awaiting in even more hostile and distant environments. When Mars returns to the center of attention, it will no longer be just a bold dream, but a technically viable objective supported by accumulated practical experience. If you enjoy understanding the strategic background of the new space race and want to follow this historic transformation, subscribe to the channel right now. And I want to know your opinion in the comments. Do you believe we should fully consolidate our presence on the Moon before advancing to Mars? Or should we accelerate and take the risk of the great interplanetary leap?